Hello friends, this is today's topic is calculus, and let us see what is the basic theory of calculus today, right? So let us start. What is calculus? Calculus is nothing but the rate of change of a certain property of an object. Now everything in real life is changing, it has a rate of change. For example, velocity changes as per the time. Money value changes with respect to time, right? And our health also changes with respect to the age. And rate of absorption of a medicine in our body also changes with respect to time. So everything has a rate of change. So how do we calculate this rate of change for each and every quantity, like velocity, money? How we calculate the rate of absorption? How we check our health, which changes with respect to the age. So let us take a small graph on which is a dt graph. On the y-axis we have a distance, on the x-axis we have time. Let us take 2 points on this graph. One is over here and the second point is over here. Now let us say the time value over here is t is equal to 2 and the distance it covers is 3 meters. Let us say another instance of time, which is t2 is equal to 6 seconds and the distance it covers is 6 meter. This is 6 meter, right? So if we say average velocity, then we say d2 minus d1 over t2 minus t1. That is the difference in the y-axis divided by the difference. This is the y-axis and divided by the difference in x-axis. So if I do d2 minus d1 over t2 minus t1, it is 6 minus 3 over 6 minus 2. So 6 minus 3 on the y-axis, this difference, and 6 minus 2 on the x-axis. And hence my average velocity is 3 over 4 meter per second, which is 0.75 meter per second. Now this is nothing but the slope of the graph. So this is the slope of the graph basically, right? Because it is rise over run. So slope of the graph is denoted by rise over run. So this is the rise on the y-axis. On the x-axis we have run. Now this means rate of change of any property is indicated by the slope of the graph, and it is the ratio of going x units horizontally, which is run, and how we rise vertically, which is rise. So it is rise over run basically. So slope is rise over run. Now let us take a parabola. Because how we find that in the previous graph we had a straight line, so it was easy to find the slope of the graph. But how do we find the slope of a graph when we have a curve? So let us take the example of a parabola, which is equation of the parabola is y is equal to x square. Now we draw a second line. This is the second line which passes through point P and P1. So this is point P1, this is point P. So it intersects the curve at point P and it intersects the curve at point P1, and this line is known as the second line. Now what we do is we want to find the slope of the curve at point P. We want to find the slope of the curve at point P, but the graph, in this graph, the line is intersecting at 2 points P and P1. So what we do is, keeping point P as the fulcrum point, we rotate the second line, and the point P1 we want to find the slope of the curve at point P. So what we do is we need a tangent line at point P. So we can find the slope of the line, which will become the slope of the curve at point P. So in order to find the slope of this curve at point P, we need a line which will be tangent somewhat this way, and when we find the slope of this line, that will become the slope of the curve at point P. So how we find the slope of the graph at point P? So what we do is we rotate this second line. This is the second line which we had drawn in our previous graph. Now we rotate this line this way, as shown by this arrow over here. So what happens, the second line takes the position of line 2, which intersects the curve at P2 and P. Right, this is point P2 and this is point P. We further rotate, so we come at this position, line 3, which intersects the curve at point P3 and point P. Slowly as we go on rotating this line, a position will come where the line will be tangent at point P, and that becomes our tangent line. Then we find the slope of this line at point P, and that gives us the slope of the curve at point P. And now what happens is, in this graph, as we are rotating this line, the point P1, it approaches towards point P. So P1 takes a position of P2, right? Then it takes a position of P3, and slowly P1 goes towards point P. So let us consider now 2 points at h distance apart in this graph over here. So we have 2 points. One is x, which has a coordinate of x and fx. Another point is x plus h, where h is a very small distance, and y value will be fx plus h, because generally we denote equation as y is equal to fx. Now, as per our equation, slope is equal to y2 minus y1 over x2 minus x1. So this is our slope formula. We use this formula, and then we calculate the slope between these 2 points. So we get fx plus h minus fx over x plus h minus x. So this is my basically y2 minus y1 over x2 minus x1, and this is nothing but the slope. And since this h value approaches 0, we can write with limit function. So we say f prime x, which is the derivative or the slope of the graph at that point P. So we say limit h tends to 0 fx plus h minus fx over h, because when this h value approaches 0, this point P1 will approach P on the graph, and that is why we are taking limit. So we say limit h approaches 0 fx plus h minus fx over h. This is the slope of the graph at that point P, and hence this is the fundamental equation of calculus. This equation helps us to find the derivative of any curved graph at a particular point on the graph. So, and f prime x is called the derivative of the equation, and it is also known as fundamental equation of derivative. So this is the basic theory of calculus. So now we will study more in detail about the various methods of derivatives when we have different types of functions, right? So I end over here right now, So I hope you must have understood the basic theory of calculus. It is nothing but the rate of change. For a straight line, it is very easy to find the slope, because rate of change is nothing but the slope, and we find the slope with equation rise over run. But what happens when we have the curved graph? So then we take 2 points at a very small distance h, and because when we rotate this line, so what happens is the point P1 approaches point P slowly as the line is rotated along this arrow direction, and hence we can say if they are h distance apart, 2 points, we can use the limit function, and then we can say limit h approaches 0, fx plus h minus fx over h will give us the slope of the curve at a particular point. Okay, if you like this like this topic, you can subscribe my channel, and you will be having more and more videos coming up on different subjects in math, physics and mechanical engineering. So have a nice day and enjoy your day. Okay, thanks, bye.